Hello guys, welcome to LeetCodes, and in today's video we will discuss LeetCode question 142 that says linked list cycle 2. So here you are given the head of the linked list and we need to return the node where the cycle begins, and if there is no cycle simply return null. Okay, so along with the head you are also given one position here, but this position is used internally to compute the cycle of the linked list, and so please don't consider it, it might be a little confusing. But yeah, originally that the position is not passed as a parameter, it is only used internally, and yeah, you will only get head as a parameter. So you need to use only the head of the linked list to determine if there is a cycle or not. So yeah, let's say for the first example, as you can see that starting from 2 there is a cycle, like from 2 to 0 to 4 and again to 2. So we can say that yes, there is a cycle and it is at a node 2. So we need to return the node where the cycle is present. So it is at this node, so we return this node. Okay, now here the cycle is at the node 1 itself, as you guys can clearly see. Starting from node 1, this node 1 to node 2 gets connected to 1, so the cycle is at node 1. Here there is no cycle, so we will simply return null here. So I hope you guys understood the question, that what we are trying to do. We are simply trying to return the starting node of the cycle. Now for the basic intuition part, how you can know that whether a number is repeated or not. So let's say you have some simple array like this, like 1 2 3 1 2 5. Okay, so how you guys can tell that whether a number is repeated or not? See, you can see that 1 is the first repeated number, and if you want to tell that how you can tell that any number is repeated or not, or if you want to find the first repeated number, then you can simply do this by using map or something like set data structure. So if any number is present, already present, then we can tell that it is repeated when we encounter for the second time. So yeah, that simple approach will also work here in the linked list part. So we took one set of list node, this is the data structure list node, and we store the nodes. So if any nodes whose value is repeated, then what we can do, we can simply return it. So that means, see, what we here check, the if node.find head equal to node.end, that means the node is not there in this set of nodes. Okay, then we insert it, else we simply return this head. Using this head pointer we are traversing, so we simply return the head. Okay, so that means we have inserted 3, node 2, node 0, node 4, but after traversing from 4 we again get node 2. Okay, so whenever we encounter this type of situation where a node is already present in this set, then we will simply return our pointer. Simple as it is. But guys, this approach takes space complexity of big O of n, and here the follow-up question asks you that can you solve this using big O of 1 memory or big O of 1 space complexity. So yeah, we have to find some better approach another than set, so that we don't use any extra space in that. Now there is one specific approach to solve this question, and I will discuss directly that approach, and that approach is Floyd's algorithm. Floyd's algorithm, or you can simply say it is cycle detection algo in linked list. So this is simply the Floyd's algorithm or cycle detection algorithm. Now here the question arises how this Floyd's algorithm will work and how it will work. So I will discuss the approach to solve this question using the Floyd's algorithm. See, there are two things, two pointers that we use in Floyd's algorithm. One is slow pointer and one is fast pointer. So this slow pointer travels to the next element. It travel next element. See, what with the help of pointers, what we simply do, we travels to the next adjacent element. Simple as it is. And here in this fast pointer we travel next to next element. So this means this will travel one element at a time, but the fast pointer will skip one element and travels, so at a time it will traverse two elements at a time. Simple as it is. So let me take an example here. Let me take a linked list and try to show you that how this slow and fast pointer will work to detect a cycle. So guys, as you guys can see here, that this is the linked list, and there is a cycle here at a node 2. Okay, there is a cycle because from 5, next pointer of 5 is pointing to 2, that is already traversed before. So yeah, now we will do a dry run how slow and fast pointer will work. So initially at this position both slow and fast pointer would be there at the initial head. Okay, Now in one iteration slow will travel to the adjacent but fast will travel here. Okay, so let me write s1 and f1, so in one iteration. Now in the second iteration slow will travel here, so it s2 it would be here but fast would be here, like it will travel to pointer. Now s3 would be here. Now f2 would be not here, if here this would be f3. Okay, simple as it is. It will traverse to one this and second here. Now s4 would be here and f4 would be here. So as you guys can see that in the fourth iteration the slow and fast pointer collide. These two pointers collide, and whenever this happens, whenever both the slow and fast pointer collide, we can say this this tells us that there is a cycle. This denotes that there is a cycle in a linked list. Whenever some pointers collide. Okay, now but what we need to return, we need to return the head of the cycle. Now the question arises how to find the head of cycle. Okay, so for that, after whenever the slow and fast pointer collide, so at this point they collided, we take another pointer, the third pointer. We can so we take third pointer, and that starts from the head. Let me take it as entry pointer. Okay, so now the entry pointer will start from here. Okay, and we simply use slow pointer again. So currently slow pointer is here, entry pointer is here. Now they both will travel. So in one travel the entry pointer will come to here and slow pointer will come to here is again. Okay, s5. So when the entry pointer and the slow pointer will collide, we will get our answer. So the collision node of entry pointer and slow pointer is our starting node or node of cycle. So this collision where entry and slow pointer will collide is the starting point of our cycle. Now this is the thing, but there is some mathematical explanation to tell you that how this works behind. So I will take the same example again. It is 1 2 3 4 5 and this is here. Okay, so now I will take so means there is an obvious question that why we have to take the third pointer, why the third pointer will start from the beginning. Okay, there is some obvious question. See, slow and fast pointer will collide, that we know this is a collision point, but how to find this head of the cycle? So for that we took the entry pointer. Now to explain you the concept of why we use the entry pointer and the slow pointer again to find the head of the linked list, then yeah, this is the explanation for that. So as you guys can see, this is the initial position, this is the cycle init. So this is where the cycle will start, and this is collision, where the collision has occurred, this node. Okay, so I will take some of the distances. See, L1 distance is let me take it as the distance from the initial position to the cycle initial. So where is the head of the cycle? It is distance between init and cycle init. Okay, let me take L2 as the distance between cycle init and collision. Okay, so let me take these two distances right now. Okay, clear till here. Now let me take another variable C, that would be the length of the cycle. Okay, so now we will use these variables. Now as you guys can know that first thing, what would be the distance traveled by the slow pointer? Distance traveled by slow pointer, what it would be? It would be simply this distance from the initial to the cycle head, and from cycle head to the collision. This much distance it would be traveled by the slow pointer. Okay, so that would be L1 plus L2. Okay, now distance traveled by the fast pointer, how much it would be? It would be how much? So it would be simply from the starting node to the cycle head, that is L1, from cycle head to the collision point, that is L2, plus let's say it has taken n times round of this cycle, so I will take n times c. So that means it has traveled n times the length of the cycle. Okay, got it. Now the third thing is third intuition, or third thing we know is twice of slow pointer length equals to fast pointer. That means that twice the distance traveled by slow pointer equals to fast pointer, because fast pointer travels 2 points at a time. So if we so in order to match the distances traveled by them, we have to multiply 2 here. Okay, that means 2 times L1 plus L2 equals to L1 plus L2 plus n times c. Okay, now remove one L1 L2 from here, then you will get L1 plus L2 equals to n times c. Now if you take L1, then it would be simply what, nc minus L2. Okay, now you have derived this formula. Now remember this, L1 equals to nc, that is the cycle length, minus n2. Okay, right, you can simply also write this L1 is equal to n minus 1 times c minus L2. Okay, simply as it is. See, we just took one cycle length from here. Okay, now the thing here is, see, what is L1 here? This much is L1, right? And this much was L2, and total was cycle length. This total was what? It was cycle length. Now what is our answer? L1 equals to nc minus L2. Now see, L1 is this much, and c minus L2. So let's say so let us take L1 here is length 1, L2 length is what, 4, and c that is cycle length is 5. Okay, now L1 equals to c minus L2. See guys, so as you guys can see here, that L1 equals to what, c minus L2. See, 1 equals to 5 minus 4, this is equals to 1. So so this is satisfied. Now if you are still any confusion, now let me explain you this once for all. See, this is the, let us take this is the starting point, this is the head of the cycle, and this is the cycle. Okay, there would be some linked list like this. So what is this distance? This distance is L1. Now c is what? C is the perimeter of this circle. This is c. And what is L2? L2 is distance of the head of the cycle up till what? Up till some collision. Let's say collision occurred here. Then this distance is what? L2. Okay. Now as our formula says, L1 equals to what? C minus L2. C minus L2. See, L2 is this much, and C is the complete. Now what is C minus L2? So this part, this remaining part is what? This remaining part is C minus L2. Simple as it is. For a circle, this is, if this is L2, then C minus L2 is this, because complete is C, and so C minus L2 is this part. Now as the formula is saying that L1 equals to C minus L2, this both distances are same. Then if you start one pointer from this collision node and one pointer from this head node, and you will traverse, then you will meet at this point. Simple as it is, because the distance from here to here and from here to here is same. So I hope you guys now understood that how this formula works here. Okay, this is the visualization, right? This simply states that. So see, what is this? The distance between start of linked list and head of cycle. Okay, and what is this thing? The distance between collision node and head of cycle. Okay, these two things is what it states. So if we start a pointer at this point and one pointer from the collision, then we both the pointer will eventually reach at what? Reach at head of the cycle. And that's the reason that if we start take one entry pointer and take one pointer where the collision occur, and if you start traversing, you will always meet at the head of the cycle. And that is the reason that you will get head of the cycle if you do this. Okay, so I hope you guys understood this. Going through the approach, now let me show you how this slow and fast pointer will work. So as I told you that we will first take this slow and fast pointer that will point initially to head. Now we will now, as I told you, the slow will point to one step and fast point to two steps. And whenever we get something like this, slow equals to fast, that means that is a collision point where the collision occur. Now from the collision point, what we take one entry pointer that is from the starting of the linked list, and slow is what? The collision point. Okay, currently slow will be pointing to the collision node. So one pointer from the entry of the linked list, one pointer from the collision node, and whenever they both will be equal, then that would be our head of the cycle. Okay, so at that point we will return slow. Got it? So this loop will work until they both are not equal. Whenever they would be equal, we would simply return slow. I hope you guys understood this. One pointer from the starting of the linked list, one pointer from the collision node, they both will end up to head of the cycle. And this is what we are doing here, and this is how we will return our answer. And yeah, the time complexity here would be big O of n, and the space complexity would be here big O of 1. So this is very much better approach for this question. And yeah, if you have guys any doubts, then make sure you let me know in the comment section. Also, if you have any feedback, then do let me know in the comment section. Make sure to like this video and subscribe to our channel. Thank you.